All right, folks, let's get back into it again. I wanted to create this video as a reminder of what we were doing previously to the spring break. I wanted to talk about shifts and translations again, just as a reminder. Do you guys remember shifts here? Now, in the situation I was dealing with originally, we had situations like this. F of x minus a, y minus b equals some constant versus f of xy equals c. These are the same c's on that side there. Okay, so those are the same. Okay, the thing that I've changed here in my imagination here is I'm thinking about this. I've replaced x by x minus a, where a is some constant, and y has been replaced by y minus b. And then we're wondering, how do these compare? Okay? How do the graphs compare is really what I want. Okay? Now, to compare the graphs, sorry about that, I had to let the cat out. Anyways, do you remember what we said here? The graph of the first guy, f of x minus a, y minus b equals c, is the graph of f of xy equals c shifted. Now I'll expect you guys to know this when it comes to that quiz. Okay, remember this was what? A units in the x direction and what? B units in the y direction. Okay? I'll expect you guys to know this when it comes to the quiz here. Let's take a quick example. If I went like this, x minus 2 squared plus y minus 3 squared equals 49 is the graph of, let's make this a plus here, is the graph of x squared plus y squared equals 49 shifted. And then I might leave you with this blank to fill in. Okay? If you come up here, if this, I'm thinking about this is my original graph, I've replaced by x minus 2. Now remember that the x minus 2 would correspond to what? X minus a. That means a is actually 2 here. Keep that in mind. Likewise here, y has been replaced by y plus 3. That is y minus negative 3, so b is negative 3. So I come up here, keeping those in mind. Shifted then what? 2 units in the x direction and minus 3 units in the y direction. Okay. Now, some people might say, what, this is minus 3 units in the y direction. That would be, what, 3 units down. But instead of doing that, what we're going to prefer to do is go ahead and just use sign numbers and then say you're shifting in the x or y direction. Okay? By the way, if you come back here, and you guys remember, just as an aside here, this problem's really done here, but just as an aside, do you guys remember that a circle that looks like this, x minus h squared plus y minus k squared equals r squared, has what? Center hk, centered, center hk, and radius equals r. If you guys take a quick second here and think about this one up here, this would mean what? H is 2 and k here would correspond to minus 3. So the center here of this circle would be what? 2 comma minus 3. The same thing here, what? The center would be the origin. Now the point 2 comma minus 3 is what? 2 units in the x direction and minus 3 units in the y direction from the origin. Okay? All right, just an example of showing you this working. You think about taking this circle here like it's a rigid object and just grabbing it and moving it. So the center actually moves along with each point on the actual circle. The radius here you can see is actually 7 because the 49 corresponds to r squared. Okay? So that's just a quick reminder of what we were doing with shifts. Okay? All right. Okay, let's consider what is really a specific case of the previous one, where the case where, so this case where y is a function of x. Okay? All right. So let's say we're going to start here. This is our original function, our original graph. Okay? All right? Now, suppose I do this. I go y equals f of x minus a plus b. Now, it's probably very easy to see that you're actually shifting b units in the y direction. Now, b may be a negative number, remember. Okay, so it could be up or down. But what? You're shifting b units in the y direction. Here, what are you doing in the x direction? You're replacing x by x minus a. So you're actually doing what? Shifting a units in the x direction. Now, to make this look like the previous situation, okay, to show you that this is just a specific instance of what? That more general situation that we've already talked about, where I've got a function of two variables, x and y, set to a constant. We were calling that a level curve. That's actually Calc 3 language. But the idea is, our more general situation, it didn't need to pass the vertical line test, okay? But if it does pass the vertical line test and you write it this way instead, let me show you. I can rewrite it so it looks just like our previous situation here. And we'll write our conclusions real fast here at the bottom. Take a quick example here. Okay, so take this one. Let's go ahead and rewrite this one. This is exactly the same as doing this. So I'll use this double arrow here, biconditional. I could add negative f of x on each side, and I would have 0 over on the right. Now, I could consider this thing a function of two variables, x and y. So maybe I'll call that thing g of xy. And that's set to 0. Okay? Alrighty? Alright, that's a weird way of transforming this and making it look like this, where I've defined g this way. Okay. Let's take this second one here. Alright, so we'll go like this. I'm going to do something similar. I'm going to move this guy over to the other side. So I'm going to go, oops, I should really do this. I've got negative f of x minus a plus, I'm going to use parentheses here, y minus b is equal to 0. Now, if g of xy is defined to be this up here, what is this? This would be what? G, let's see, what did I do? I just took g and replaced what? X by x minus a, and replaced y by what? Y minus b here is equal to 0. Okay. Well, wait, how do these two compare? These are the same constants on this side, right? So this is a very specific instance of what we've seen already. How do these two compare? Well, this guy would be what? This guy shifted a units in the x direction and b units in the y direction, okay? So it's going to be the same here. So I'm going to put this in here. So clearly what's happening here, y equals f of x minus a plus b is y equals f of x shifted a units in the x direction and b units in the y. In the y direction. I guess I've been underlining that because you guys are going to have fill-in questions later where you have to do this. Okay, so there it is. Now let's take a particular instance of this here, okay? So we're going to write it like this up here. Let's go ahead and try something like that. Okay. Let's take a concrete example here. Y equals x squared versus y equals x minus 1 squared plus 3. Okay? All right, so here. Y equals x minus 1 squared plus 3 is the graph. I should really say the graph of blah, blah, blah. But there it is the graph of y equals x squared shifted. Okay. Let's see. What did we establish? What's my a here? My a is 1. Remember, because it's x minus a, so a is 1. So it shifted a equals 1 unit in the x direction, and was b units in the y direction. So b is 3 here. 3 units in the y direction. Okay? Now we could actually graph that on Desmos and we could see this working here. Here I went ahead and actually did graph the two functions in order to compare them. Here I graphed them on Desmos. If you guys look at the red parabola here, this is our quintessential parabola, y equals x squared. So imagine starting with that one. And there's where I had what? Y equals x minus 1 squared plus 3. You guys notice it indeed looks like what? We shifted 1 unit in the x direction and 3 units in the y direction here. This point at the bottom of the curve here, what we call, remember, a local minimum. In fact, it's an absolute minimum as far as y values go here. This is called the vertex, okay? Notice that this has what? A vertex at 0, 0. This has a vertex at what? 1, 3. So I've taken the origin and shifted it over 1 unit in the, or not the origin, the vertex of the original, which was at the origin, 1 unit in the x direction and 3 units in the y direction, and we get the vertex of the second parabola. Okay? Just an illustration that we were indeed correct in working out the previous problem. Okay?